last time so the first episode, we basically got this working, blinking LEDs and stuff like that, and touching pins and reading inputs. Then in the second episode, we took that and we turned it into actually reading like the matrix scanning logic. So reading through the keyboard matrix, outputting key presses. So now we have an actual sort of kind of working keyboard. This episode, I'm going to be cleaning up some of the logic in terms of macros, making things more efficient, and we'll see how we actually save a lot of program memory by doing things in not such a naive way as we did before. Yeah, I have also, so for ChipCam, I now also, you can't see it, but I now have a big red square on my screen where the ChipCam is, so I can actually tell when the ChipCam is live, so that I know that we're not doing anything wrong with that. So just to recap, when I now, with the code we have running on this right now, it basically prints out the coordinate of the key that I press. So this key, like bottom right, is sort of 0, 0. And in this direction, we have numbers. And in this direction, we have the home row on a Dvorak keyboard. So these will be mostly vowels. So as you can see, when I hit this button, it prints out 0A, 0O, 0E, 0U, 0I, 0D, 0H. And if I go up this way, I get, you can see, if I take a new line, you can see I get 4A. This is not properly implemented. It doesn't do key up and key down. It just writes these as letters. But this was just to test that sort of all of the keys were read correctly and we didn't have any ghosting, anything like that. I can hit multiple. Not quite sure what that means. We can hit multiple switches at once and they should all register fine. So if I hit these 6 keys at the same time, we get 6 key presses. So all of that should work fine. What I was saying is that since we have columns and rows defined as compile time arrays, so if we look at this, like these definitions of pins are in this teensy library, and they are objects with a port and a number, and they are used in macros to do this definition, this object, never enters runtime code. This is only used on compile time, and it rewrites them to these port like bit shifts and bit swapping operations. So this is a zero overhead abstraction from pins to and like the usage of pins, all of that is zero cost. But last time, in order to do these loops, because we can't, since these are macros that take static inputs, and this is a static array, we can't loop. We can't do something like this. We can't do something like this because pin in that case wouldn't be static. As you can see, the and the compiler complains that we got pin but expected one of macro input static pin. Yeah, so we get a pin, we don't get a static pin, and this sort of leaks our definition of pins into runtime code, which we don't want. I am still looking for a way to enforce that a bit harder, to make sure that we don't accidentally leak the pin object into runtime. I haven't quite found a way of doing that. But yeah, so we wrote this each iterator, which is just written in the most, like the dumbest way possible. So what you can see that it does, it takes a static collection of pins, an open array of pins. So an open array in NIM can be either, it can either be a sequence or an array. I think those are the only two options at the moment. There is, I think in upcoming version of NIM, there will be an iteratable thing. So we could say like iteratable pin, any collection of pin that I can iterate over, but that's not in yet. And a body, which is what we pass, with this colon here. So this is the body, and this is the collection of pins. View. No, I think there was talk about something else. Not views, but some like actual like iteratable concept thing. Oh, open array tree. Well, that makes sense. Strings are basically just a sequence of characters in them, at least with the default garbage collector. But yeah, so anyways, this takes in a static array, and it creates this iterator, and it just spits out this block for each of the pins. The problem with this is that it does that expansion on compile time. So this will expand to doing this on compile time. Right now, this code takes almost 3,000 bytes, which, as you can see, for this particular controller isn't all that much, but it's still way more than we actually need. And we'll look at that in a second. But if we look at this, and if we look at the code that's generated, so this start bit looks fine, do some stuff, and then it just goes on forever. Right, yeah, that's because I click it, and it goes away. I mean, I'm reading it from that notification on the screen. That's the only place that I'm seeing it. So yeah, as you can see, this has just expanded on compile time and created a massive, like 1,000 character long file. Of course, it doesn't help that we call each it from within itself. So this expands all of this, but this expands all of this. So this is expanded for like the sum of it, or the multiplication of it. So what we want to do is to write something a bit more clever than this each it sort of hacky for loop thing. So this, I think what we want to write is something like this, something like that, and that should do this thing. Of course, that doesn't exist yet. The thing is that this its.input, if you look at what this does, it takes the port and it reads the port, and then it does an AND NOT operation to switch one specific pin on or off, or one specific bit that we want to flip or set to a particular number. The problem with that is that when we're doing these in a loop, if you look at the C code generated, it's all the way on up here. So if you look at this, basically what it's doing, it says DDRB, so that is the B pin, and it sort of shifts it for us, so and generates this. Yeah, you can see it actually did the NOT operation as well automatically for us before it hit C code. But you can see we take the DDRB, we read the DDRB, we set one bit basically, and then we do the same thing over and over and over and over and over for all of the pins. This isn't great. I'm not sure if the C compiler might optimize that. I don't think it would be smart enough. But basically, one optimization that I want to do is because we, on compile time, we can see that, oh, all of these B pins are on the same port. They're all on the B port. So why do we call this read operation a bunch of times and set individual bits if we rewrite to this style, where I just say configure all pins in this sequence, or this array in this case, to be input pull-up? It could look at them and go, all of these are B's. I'm gonna set the pins to whatever they're supposed to be, and I read the value once, apply our shifting of bits, and then write it back once. So that will be one operation for all of the pins, all of the pins on the same port. And that will give us a little optimization. And foreshadowing, this is going to be great for later, when we get into doing the second half of the split over I²C. So I want to do that for setting pins. And this iterator has to go. We have to be smarter about that. So what I'm thinking is something. So there is a thing in Nim called a for loop macro, where we basically can get a for loop and rewrite the entire thing in a macro. So I want to do something like for column in columns with pin as, for example, and say output low, something like this. And of course we wouldn't have to do these, and it would also reset them for us automatically. And this call would be the number of the pin, because remember, we don't want to leak our pin definition. So this is just, the call here is just going to be the number of the pin, because we are going to need that to look up in our table of, or when we do layouts, we would need to look up which column we actually pressed. So this is going to be the number of the pin, and this is going to just configure and deconfigure pins for us. And just to sort of show, so I've done some testing with this off camera, and to just sort of show, well, okay, I won't actually show that. Let's just implement it. So this is really a teensy specific bit. That is where all these macros live. So I think we're going to implement them in there. So let's start with the configure one. Columns.configure and a variable amount of things to be configured. Macro configure. The pins are going to be a, what do you mean the keyboard comes with a circuit? Open array of pin objects and states, let's call them, which is a var arg of untyped stuff, because we don't, since these input output things won't really have a type. Well, they will have this type, but we don't count those. This just gonna spit out untyped. And let's just say something like that, so that we get rid of all of the red stuff. We need to keep track of our ports. So we need to sort of collect all of the pins on the same port. So in this case, for example, we have the D port and the C port. So doing this configure for the rows are actually gonna spit out 2 commands, obviously. So we need to keep track of which pins for which port that we're setting. And I think, I mean, we do have a number of these, but let's just do this with the easiest way of getting the job done. So we just say port is a table going from a character to a sequence of ints. And then we loop through our, for pin and pins, ports, pin, and that is called port and num. So for pin.port, add, I think this will work. We need to do get or default, mget or default, and it defaults to an empty array, and we add the pin number. And let's just echo out this table. Anyways. Yeah, so now let's not actually do columns, because columns is just these 5. This one, since it has multiple ports, is a bit more interesting. You will also notice that columns are 5 and rows are what is that, 7? If you look at my actual keyboard, I have 5 rows and 7 columns. That is just because of the sort of the terminology of this matrix layout. So the thing that connects through diodes is typically referred to as the rows, or as the columns rather. But for me, since I wanted it to be super low profile, I found it easier to do the rows as columns, the other way around. Doesn't really matter, but the terms in the code is a bit confusing. We could easily add a flag that hides this. So when we get to doing layouts, we will probably hide this, or just let you say where are your diodes pointing, to columns or to rows? But yeah, so rows configured, configure rather. That's called configure. So if we now run this, just compile it, we can see we have C 6 and 7 and D 0 through 5. And if we look at our code here, we have D, D0, 1, 2, 3, and 5, and we have 6 and 7. Yeah, we're actually missing 4, which is good. So now we have them in their sort of ports definitions. Now we need to generate the code to switch them. And for this, we are gonna have to look at our states. So, what is the type of this? This would be var args. So I guess just for state and states, echo states the tree wrapper, just to see what we get here. Oops. Oh. So our make file doesn't list the TNC or keyboard file. So making changes to those won't trigger a recompile. But now it will. Yeah, so we have identifiers, inputs, and pull-ups. We are just going to do an EC assert here to say that state.kind is a nym node kind. That is what NNK stands for. Nym node kind identifier. And just spit out an error. Only single or only simple identifiers accepted. And we are going to, we could do that in a case statement actually. So case over, I think it's something like this. So if it is input, we're gonna do that. If it is, just write discard here for now. If it is output, we're gonna do this. If it's pull up, we're gonna do this. Oops. And if it's normal, we called it. It's probably a bit of a misnomer. If it's high, or if it is low. So these just correspond to these up here. And in case it's none of them, we are just going to say assert full or assert state.serval in input. I wish there was a better way of doing this. I mean, we could do just assert false, but that wouldn't really tell the user what their error was. I don't like using assert false. So if you just make, you can see we don't have an error. If you now write something that we don't accept, for example, try to configure a pin as a dog. That shouldn't have worked. Is this because we are compiling in danger mode? Yes. So, bit annoying. Asserts only work in debug builds. We won't really ever do a debug build I mean, we could do something like this. Oops. I didn't mean to do it like that. We could do something like this and just say like debug and do something like that. I actually don't have to optimize for size either. So that this will actually trigger our debug symbols. But we never really want those to be visible. So now this will make an error. But we don't really. So we're never really gonna need a debug build of this, apart from getting better stack traces. But we're not getting stack traces because we're running on a microcontroller. And for some reason, errors in macros are also swallowed, even though they are compile time when we do the release flag. I think there might be a way to throw errors from macros, but I'm not entirely sure. Yeah. So now we should be in here, because remember we have input and normal. So what do we want to output for this? We want to output. Whoa, that's not what I meant to do. Input. We want to output this thing right here. Port is equal to port, and not and pin definition, but we want to create ORs for all of our pins per port, right? So we're gonna have to make this, not this number, but we are gonna make this port. Oops, I didn't mean to click that word. Let's do this. So down here, so now we have to go through all of our ports in the port table for port, and what can we call this? Let's just call it pins in ports.pairs. So pairs is an iterator that gives us key and value for a table. So this will now be all of the keys in the tables, and this will be the sequence of pins. Ooh. We're gonna have to rename one of these. We're gonna use this, so let's just call this like port name. The register for input is DDR because it switches the direction, so input or output. And then we are gonna have to loop over our pins. So for pin and pins, and we are gonna have to create a sequence of O-rings of this kind. So we are gonna start with, I guess, so let's call this just value mask. This is the new literal for uint8.high, which should be all pins turned on. So O-ring, O-ring onto that should just give us the pins. Oh no, anding onto that. This should be 0. Because O-ring onto 0 will give us the right thing. So value mask is equal to quote do value mask or 1U8 shift left pin. So remember, these are integers. Shift left pin amount. So now we have the mask of things, and now we need to add the setting for this port to our result. Result.add quote do, and we're going to do port and not value mask. Let's echo out this. That's a great thing with the result variable in nim. So since it gets highlighting, it's really easy to track down when you're doing changes to it. And you can easily have a look at it. So even though I'm only calling one thing and returning one thing, I tend to assign it to a result if I want to in the future echo out what that thing prints out, which is nice. Let's have a look at this. We can remove this dog. Make. There we go. So we can see what it spits out here now. It has one assignment to DDRC between edent and then this whole shebang, and one to D. If you just spit this out as where did we put those? Put those here. If we output this as just code, like code representation, we can see that we get this. DDRC is DDRC and not 0 or 1U shift left 6, shift left 7, and 0, 1, 2, and 3, which should be what we need. So now we have to do basically the same thing for all of these, but they're all just going to be different these bits. So I'm going to move this out of this. So we build the value mask only once outside of this case statement. Yeah, this needs to be inside that loop. And then all of our branches will just be the logic, the input output logic stuff. So for output, we are going to do output is the opposite, so that is an OR. And right, so we need to change this. Crap. Yeah, so this part needs to go in here. Oops, what did I hit there? There. And there. Output is also DDR, so that's fine. Pull up is obviously port, and pull up is an OR because we want to set it. Normal, that is when it's set to low, so this should be and not. High is obviously OR, and low is and not. Yep. So that should. Why is this complaining? Oh. Remove these discards. There. That should make that happy. We should be able to compile it. And it says, okay, so DDRC reads DDRC and removes. So the 0 is just to sort of start the statement off. Shift left 6 and shift left 7. So C, 6, and 7. And the D port, we have 0, 1, 2, 3, and 5. 0, 1, 2, 3, and 5. And the same for port. So that is 0. Yeah. Or 0 or. I think this should work. The representation here hasn't output parentheses for us, but the tree should be good. Okay, so if we now, okay, so first let's have a look at this. That is 2,966 bytes. If we do this, this shouldn't be a massive saving. 2,962 bytes. So we have saved about 4 bytes. It's something. It's not a lot. It's not a lot, but it's something. And this should also be input and pull up. And of course, our code looks cleaner. So that should have saved us another 4 bytes or so. That actually saved us 8 bytes, it seems. Six plus the 2. So that saved us a bit more for some reason. So if we look, so if we go back to this, let's put columns down here. Do this. So if we do this and we look at this C code, we can see that the C code we had is take this, read this. Oh, this is the one for turning the LED on, I believe. So yeah, take this, take this, set that, and that is, let's see, a little bit of cheating, but that is, how many lines? Doesn't it say? That's a lot of lines. If we do this instead, the generated C code, oops, must make it first. The generated C code looks like this. Much cleaner. So now we just say set DDRB, read DDRB, set it to this mask, this mask, this mask. And these masks, so if you look at the OR ones, and if we just fire up a calculator nice and big here and say 192, convert that, oh, not to hex, to binary. We can see here that it's set the 7th and the 6th byte of port C to high. Which is pull up. So you can see it generates only one statement for each of the ports, which is nice. So that has saved us a little bit. At least made the code way cleaner. And as I was saying, when we start doing the I2C stuff, we now have a nice abstraction. So this each it thing, that's a bit trickier. Basically what we want here is to create a loop that can do stuff like this for us and revert it at the end of each loop, obviously, and then run some code in between and keep track of which number we're at. So this is a bit trickier. And we have to write what's called a for loop macro, which are a feature of NIM that not a lot of people are using in NIM. So a for loop macro is a macro that takes, I'll zoom this in a bit. Where did it go? A macro that takes as its only input parameter an expression of the special type system.forLoop statement. Can rewrite the entirety of a for loop, which is what we want. So if we look at this, enumerate here takes a for loop statement. Yeah, not a lot of people use these, but for this specific thing, it's perfect. We could have used expect kind. So in here, when I say assert that this is of a specific kind, we could have done this. So we could have said expect kind. I don't think this takes a custom message. No. But it can check the values for us. We still need to do that ourselves. Yeah, so what you see here, we take this NNK4 statement and it builds basically the whole thing, and now we can do this. Unfortunately, they don't support, and this is a bit annoying, they don't support the unified call syntax. We'll look at that in a second. So, as I was saying, we want something like this, for column in. So we can't do this. We want these to be output low. We can't do this because this won't get recognized as a for loop macro. We have to write it like this, at least for the time being, which is a bit annoying. For now, let's just copy this into there. Actually, just for now, something that we can see in the C code. Just run discard there. So, with pin S, let's define this. It is, and let's not do that anymore. With pin S, and they take this for loop statement as their argument. So let's do this for loop statement. Output untyped. And the only thing we really want to do right now, just give me that as a true representation, and just create basically an empty return statement, just so you won't get any complaints. Undeclared identifier with pin. Oh, so we obviously need to export this from our module. There we go. So here we can see what we get. We get a for statement. It takes an identifier. That is the identifier here. So probably we want to assign this to something, or like create a loop that assigns this to something. Oops, where did that go? Here. Then we get a call, which is our invocation of the macro. So here we can read our arguments. And then we get a statement list. So this is what the user wants to run for each loop. So let's do the same thing as in the example. Do this expect kind NNK for statement. So in here, we are gonna do expect kind of loop to be an NNK for statement. And then let's grab our iterator. Oh, we can't do that. Our iterator, our iter variable to be loop 0. So that will be this identifier. And then we need to grab all of the arguments of this call except for the first one. So the first argument is going to be what we're going to be looping over. And that is going to be, we're going to have to get that somehow. You might actually need to double nest this. So our pins collection is going to be loop 1, 0. So 1, so of this we have 0, we have 1, we have 0. So we actually want to grab 1. 1, 1. And our arguments, or our states rather, is going to be loop 1 and everything from 2 and out. So now we can echo out these, just do them as a repr. Oops, let's see what we have here. So we have call, we have columns, we have output, and we have low in the sequence. Great. Yeah, so now we need to somehow get the columns static variable. And I think we might actually need a... no, we actually don't need to... Oh yeah, we do. We need to read that. So basically what I'm thinking, we want to turn this statement into something that looks a bit like for column in 0 ... columns dot high. So that won't leak the columns array of pins. It will only echo out. This will only be the length of the number of pins. So that has satisfied basically this and this. The fact that call is now the number of the currently iterated pin. And then, because all of this is now runtime, we need to do these outputs and low based on the pin number. And we need to expand this, or this rather, on compile time. So what we're going to output is something like this. So do a case of column if it's the 0th element. So if it's this one, then we do b0 dot output, and then we do b0 dot low. If it is 1, then we have to look at the next one and do b1 dot output, b1 dot low, right? Why is this complaining? And basically do this for all of the cases, and just to make so cases in them, we have to cover all of our cases. So for call, which is now in this range, this is an integer, we have to cover all integer cases. But what we can do is we can cast that, and of course in a macro, this isn't any actual extra typing for us. So we can cast that to this range, and now we'll just check that we are matching all of the ones in this actual range. So for B2, that would be B2. B3. And the last one, 4, is that's right, B7. Right. Yeah. And then we are gonna, so this is gonna be our first thing. We also need to sort of undo the one from before, right? So, or we can also do that at the end of the loop. That will actually be easier. But we might, yeah, we'll do that first. So do these, and then after the loop, we need to do the opposite. So here is our body, and then we have to do the opposite, which would be input pull up. So remember, low is 0 in this pin register. Pull up is 1. So pull up is the opposite of low when we're switching from inputs to outputs. We might have to think about a smarter way of doing that, but oops. So yeah, we're gonna have to do something like this. Since these are static, can we index by okay, so before we get any further with this, let's disable this. Oops. Disable that. Let's copy this bit, which is the body of this statement. Pop it in there and disable all of this. Because this code here is basically what we want. Oh god. All of this is basically what we want this macro to spit out. So let's check if this works. It should compile just fine. And if we upload it to the actual keyboard, So I'm gonna switch you guys over to ChipCam. I'm gonna hit the reset switch on the back. You can see there in the background it's updated, and this should now still work just fine as our keyboard. Great. So now we know that our macro will work if it outputs this. If the macro outputs the code that we have here now, it will work. I am curious though, can we do, is Nim smart enough to see that this is a static pin? I think it should be. Damn it, it's not. Oh yeah, because this is runtime. Right. But it would be smart enough for this. But all of this is going to be evaluated on compile time, so we won't actually have any overhead. Yes, okay. That compiled. The reason why I wanted to check that is because for this, for outputting this, we have to actually read the columns thing, and we have to get these out. What we have in our macro here now is just the identifier. So we would have to double wrap a macro, like this would have to generate a call to a macro where this would be a static input parameter, which would be ugly. But since we can do this, we can easily just generate columns 1, columns 2, and then have the compiler sort that out when it compiles. So let's do that. What we need this with pin as thing to do. We need to iterate over all of the indexes in this, or indices, not sure how you say that. Then we have to generate this case statement and all of these case branches. Ooh, but we have to know how many of them there are. Damn it. I think we might have to actually double wrap this after all. Well, we can write a macro that just generates this. Okay, let's do that first. Let's write a macro called do we want that a macro within a macro? I mean, I think we have to, because we need to get these numbers out. We need to know how many pins are in the list. And I don't think we can get that. So we'll create a macro that does so generate case statement, whatever, for columns. Oh, and it also needs outputs and low. And here we create a macro generate case statement that takes in pins as a static open array of pin. do you mean unroll the for loop? Which for loop? Oh yeah, basically what we're doing there is unrolling the loop. Yeah. Kind of. And then states var args of untyped. We are returning untyped, and what we want to return is this case statement, right? So let us output, let's just do a dump tree of the case statement that we want. Actually, don't do all of the branches, do one branch. Oops. Let's do that, and let's just have this discard for now. And declared identifier, because we're calling this from our main code at the moment. We're going to hide that later on. Oh, just go back to just making it. Right. So what we want to generate. We want to generate a case statement with a call to this bit, and then an off branch with an input and a statement list and all of this stuff. So we are going to start by saying our result is a quote do but now we only have, now we don't have the name of it, so we actually need to grab yeah, we need to grab both columns and columns. Spammers. Like that. And grab this stuff, put that in here. Whoops, wrong key again. So this should be pin's name. We actually need to grab this as well, which is our iter variable. I mean, all of these are like, we're going to be calling this from within our own macro, so it doesn't really matter that it has an ugly signature. And just do that. This we basically just need here to make this quote do statement work. So we now have this with this. So we have 0, which is call. We have 1, which is our now intlet with just a discard here. Actually, let us just output this so we can see what we have. Yeah, okay. So since it doesn't know yet what these are, they show up as open sim choice. But basically we have a call and we have one off branch. So we are just gonna grab we are just gonna delete this first node. We don't have delete for nim nodes. Can have an else discard, but I don't think that will. I'm not sure if that will work with let's just try. I just want to check if I get a compilation error if I do. Oh, so we have that for oops, we need that. Yeah. Aha, nice. So yeah, now we only have a case statement with our call in it and no body. And the body is what we are going to generate. So for I in 0 dot dot pins dot high result dot add and now we need to create our statements, and these are gonna have to be off branch statements with an int literal, which we already have, and then a statement list of the calls to these don't have to be dot expers, but a bracket exper with output. So let's rewrite these. This is just the unified syntax call thing. But this style of calling makes for a slightly easier AST to generate. You see, we don't have to generate this dot exper. It's just slightly bit easier. So off branch with intlet, we need a statement list with calls to this and this bracket exper. Call syntax. Yeah. So call syntax is an easier AST representation than what's the other one called? Method call syntax or something like that? Function? No. Anyways, so for each of the pins, let's start with creating our body here, which is what's going to go. So this bit, and that is going to be for state in the states that we take in, and body.add quote do. So I guess it didn't really matter. States. This is pin's name. And this is, I guess we don't really, gain anything by doing it this way now. So that should have created all of the calls to set the pins. And now we do, I already have this, result.add nnk, what is it, OF branch. So nk off branch with a new literal for our I and the statement list that we just generated, which is just body. And that should new tree. There we go. Cannot evaluate at compile time pins. Say what now? declared identifier column. Yeah, that makes sense. So this is obviously meant to go inside of our loop where we have column defined. So we pass in the column identifier here, but in this case that doesn't mean anything, so just create an empty variable to make the compiler happy. Ooh. Yeah, so here we can see what it outputs. Case range 0 to column set high, column. It didn't output the line there. Or this thing, the colon. Yeah, output low. Oh, yeah, this is wrong. That's not what we want to generate. State. There we go. That made it happy. Output column 0, low, column 0, output low. That looks good. So that is that part. So now we can get back to doing this bit. With pin S, we have all of this stuff. So this is now going to have to generate this with a call to our new macro. Oops. So yeah, it's going to generate this with a call to our new macro, then our body, and then we need to generate this, the inverse thing. But let's start without it. So result, we can actually start that now as a quote do. We can say for our ether var in 0 pins high, and then we can say generate case statement with our pins and our pins again, which are gonna get captured as an untyped, our ether var, which is this thing, and all of our states. I'm not sure if that is gonna expand properly. Then our body, and echo out result as repr, because that's going to be a bit of code. Ooh. Right. Not happy with that. Internal error in seminst. That looks like something that might be hard to fix for us. Was it able to do this at all? Oh yeah. Generate case statement. But this is wrong. Don't do that. Do that bit. Actually, generate statement and body, possibly. Oh, it's not called body. Oh, we haven't extracted the body. Body should be loop. What is it that we get in? Damn it. Don't do any of this. Echo loop dot tree repr. Did I not save? Oh, here. With pin as, so that is 0, 1, 2. So body is 2. Do this. Yeah, body, and generate statement is gonna be an nnk call. The call is gonna be to new tree. The call is gonna be to generate case statement. We are going to give it itervar. No, we're going to give it pins, itervar, and this has to be a var, not a let. For state in states, generate statement dot add the state. Let's see what this gives us. Oh, we're not outputting. Let's see what this generates for us. For statement, ident column, infix, blah, blah, blah. Statement list, call, generate case statement, columns, column output low. Statement list, discard statement, and empty. Whew. That seems to have worked. So it now looks like for column in 0.column high, generate this case statement and run this discard. Great. We are going to create another one of these. Generate in statement and generate out statement. So that's in and out of the loop. And the out statement. And the out statement is going to be the sort of the flip-flop of the state. So we're just going to copy this bit, pop that in there. This is of course the generate in statement. Just empty out all of these branches. I just wanted them for their values. There we go. And then generate out statement that add. So add the output of this case. New ident node output. So this is just basically the reverse of all of these. I grabbed the new line by accident as well when I copied that. So output, the reverse of that is of course an input. Pull up, the reverse of that is normal. Normal, the reverse of that is pull up. High, the reverse of that is low, and low, the reverse of that is high. Now, for the keen-eyed amongst you, you might now notice that this will output low, and then input high instead of input pull up. But high and pull up is the same thing. They do exactly the same thing. So pull up takes port, or sit with this thing. High takes port, and or sit with the same thing. We just made them two different things to make them nicer. Why is this complaining? What? What is that complaining about? Oh. I didn't like to have that on a separate line. I was looking at there's a list of like the nim features you didn't know existed or something like that. And it had a block calling thing that I thought was pretty cool. Oh, this also technically needs to return that should never happen, so let's just create a node that says error. So this doesn't work, but this should. Yes. Cool. Yeah. So generate case statement outputs its thing. So what we see happening here is that this first outputs what it generates, then the compiler goes on and evaluates these, which outputs its result. So we can see here that this macro generates generate case statement columns, column output low, generate case statement column input high, and then this one is evaluated and spits out this thing, and this thing is evaluated and outputs this thing, and both of them seem to do the right thing. And this discard in the middle is the body, which we have set to be this thing. So if we now actually take the actual body that we wanted, which is this thing, and drop that in here, we should now, yeah, you see now we have this. Yeah. The range for the case means you don't need the else label. And it makes sure that you cover all of them in the range. It's a bit sad that it doesn't do that automatically when you do it in a for loop. Like the for loop has a static range. So it's a bit sad that like casing over this, well, maybe not that one, but like casing over this, which is known to be in this range, doesn't automatically do this. It would be cool. Yeah, so this should now work. So let's switch to chipcam and hit the reset switch. And this should now, hooray, output all the correct keys. Cool. Very cool. But this, of course, is the same thing. So we can do for row and with pin as rows, and they should be pull up. Don't do that. Do that. Don't do this. Don't do that. And then row, rows, row. Don't do that. So yeah, this has this read, which we don't have yet. And this doesn't work. So we need to write a macro called read pin, which will read the pin in a with pin as loopy thing. Just remove all of this, all of that, which we don't use. So basically what this read pin thing should evaluate to is very similar to this case statement. It's going to be something like Case, again, the range thing just for niceness sake. Something like that. And then of and all the values, and then rows 0 dot read, right? Something like this. So let's write that macro. Can we rewrite this, or can we reuse this? So that spits out this code. And yeah, if this was just read, that would work. So we could create a macro. So this is meta. We're now expanding this loop into something that has a macro in it, which is going to be generate case statement for pins, and then read. No, itervar read. Ooh. What is it complaining about here? So yeah, this macro that got output here is read pin. So this should be a call to this thing, which would generate a case statement of columns. Ooh, columns. Oh yeah, this will be expanded later. So read pin in this case should be column, read. That should be fine. But in the second, so when it expands this, it gets an error that we expect a nym node, but got a uint 8 on line 198. We can remove this, by the way. I think this might just be some weirdness. Let's try to do this. Oops. Actually, just this, and that is going to be a new event node read. And that's going to be generate read statement. Nope, still not happy. 193. That's not helpful. Got uint 8, but expected a nym node. Which part? So this returns, oh, right. This should, oh, this is meta. So this read pin should not be a macro, it should be a template. There we go. So by making this a template instead of a macro, this just generates a call to this, and this is a call to this, which creates the case statement. when it was a macro, it called this. And that is a uint. The result of that is uint 8. And we couldn't return that as untyped, which is an node. So that was the error we were getting. But by making this a template, this read pin now just expands to this thing, which is what we want. And I'm not entirely sure if I can now hide this. No. At least not without binding it. Can we bind, create a node that binds eat into a symbol node? Would we be able to do generate case statement and then use the symbol here instead? No, it did not like that. This takes a string literal apparently. Does this work? Yes. But does it bind it even if it's not exported to that module? So this should work. Can I now not export this and have it still work? Yes, great. Yeah, and we get this error that read pin is declared but not used. So we are just gonna pop a used pragma onto there. That doesn't go there, it goes here. So that got rid of that hint that we weren't using read pin. That is just to not confuse any potential users. Just gonna hide these or remove these echo statements so that our compilation isn't as verbose. Still outputting some things. Where are they coming from? This one. Obviously don't want to echo that. That is echoing out the table. Where was that? That is here. There. So, just check that everything is up and running. Switch to the chip cam. It's waiting for me to press the reset button. There we go. Booted, up and running. Hit keys. Everything is running. So, make size 2004 bytes. Compared to the 2996 bytes or something like that we had originally. So we have saved almost a kilobyte, almost a third of our program size is gone. And to me, this looks quite a bit cleaner. I mean, if I just undo all the way, since I've had my Vim open from the start, this is the code that we started with these each its and this. What happened there? My mouse ran out of battery. Not to worry. So yeah, this block of code here, that sets up our pins and keeps track of the column and row, switches them back and forth between what they're supposed to be, all of that stuff. Oh, let's just, while we have this, write that out. Make size. Yeah, 2,966 bytes. We do seem to have gone up in data. So that used 13 bytes. Our new version uses 25 bytes. I'm not entirely sure why. But we should look into that. I'm not quite sure actually what that data is. I think it's like global variables and stuff like that. So I'm not quite sure why that has grown. But we'll look into that. So yeah, if we now look at what the code that we have now, simple, configure all the columns, configure all the rows, loop through all the pins with these states, which gets toggled not to what they were, but to, like, we could have done something like read them out and change them. But the assumption here is that if I tell a pin that I want it as output low, it probably wasn't output low to begin with. It probably was the opposite of what I'm trying to set it to. So that's why we just invert at the end. And yeah, read pin. This is a bit hacky, but yeah. We could have made something that looks like that, and it's just sort of a hack thing. But this is fine. Of course, this read pin would only read this row pin. If we wanted to read the column pin, we would have to have done something like this. Oh no, that wouldn't work either. Yeah, we would have somehow managed to keep that into here without it getting overridden by this thing. I mean, we could have just read it out here. Oh, that might actually not work for all workloads. Yeah, maybe we'll rewrite this to do something like that. Not quite sure how I would do that though. Maybe some kind of weird overloading thing. Generating a something. But yeah, so our code is smaller. Our output is smaller. Yeah, so if you do make size again, we can see that we're now at 2004 bytes. So we have saved 962 bytes. We have saved a couple of lines of code. If we look at the C code, our configuration now looks like this. And instead of what we had before, which was something like 900 odd lines, this is now 350 lines. It's not the prettiest, but so this here is the loop that starts, and we're looping through this. Here we have the case, the switch case that turns the specific ports on and off. And yeah, this is for the rows. I was playing around with this earlier, and there is one optimization. Yeah, here's the body, the keyboard press stuff. Anyways, yeah, so our code looks smaller, and we're now working at a higher level of abstraction. So we're working at with like, okay, just configure all of these pins, loop through and set these pins to this, and set them back. Like, I don't care about the details, just get me to a state. We're in this state, I want to be in this state, go to this state, code figures it out. The benefit of working at that higher level of abstraction is that when we start complicating things with the second half of the keyboard over this I2C port expander, we are going to be able to put the code for that into these. So this code can stay exactly the same. We can define pins on a port expander. We can expand our definition of a pin because the user never sees the definition of a pin anyways. And we can now have pins on a port expander and pins on the device itself behave exactly the same. And have our macros sort out all of the hairy logic for us. But that's going to be in a future episode.